All right, 7.4 properties of special parallelograms. There are 3 special parallelograms that we're going to talk about. We have a rectangle, a rhombus, and a square. Okay, those are the 3 that we're going to discuss today. You should already know some properties, what's congruent, what makes it the same already, because they're pretty easy shapes, and this should not be the first time you're hearing about these. Rectangular, rhombus, and square, things you need to know about them. Your rectangle is a parallelogram, so the same properties of parallelogram, but it's with 4 right angles. All my angles are going to be congruent. They're going to be right. They're going to be 90 degrees. My rhombus is a parallelogram, so it has the same properties of a parallelogram, and then it has also 4 congruent sides. And then a square has the properties of parallelogram, so we covered them in the last lesson in 7.2, so you have them. Please don't forget them. And it also has the properties of 4 right angles and 4 congruent sides. So a square basically is the same properties as a rectangle and a rhombus put together. So that's something you have to know. You have to understand all of that. All right, corollaries. We have rhombus corollary. This is just basically visualizing it. A quadrilateral is a rhombus if and only if, so we've heard these words before. If and only if it has 4 congruent sides. Look at my tick marks. They all have 1 mark, representing that they're all congruent. Okay, so there's another way of writing if and only if. Do you remember?
Yes.
Good, it's IFF. So if you ever see me write IFF, that's if and only if. Okay. Looking at the next one, I have rectangle corollary. A quadrilateral is a rectangle if and only if it has 4 right angles. So these are what make it up. And then I have square. Okay, if and only if it is a rhombus and a rectangle, so it has both 90-degree angles and all congruent sides. All the sides are the same. So these are properties that you have to remember. All right, parallelogram. This is a Venn diagram. You guys have definitely used this in at least your English class, hopefully. I'm going to write the properties of a parallelogram that you should already know. Okay, this is information that we have already covered. So you should already know the properties of a parallelogram, but I'm just going to write them so we have them all on one slide so you hopefully can remember it. So looking at this, I have my parallelogram. Opposite sides are parallel. This is the definition. Okay, this is the definition for parallelogram. Properties of a parallelogram. What makes a parallelogram a parallelogram? The first thing we know, opposite sides. Opposite sides are congruent. What else is congruent? Good. Opposite angles are congruent. Okay, that's 2. There's 2 more. We have consecutive angles are supplementary. What does it mean, consecutive? Good, they're next to each other. And then 4, which is my last one, your diagonals bisect each other. Okay, so these are 4 things that we should already know about parallelograms. Okay, we covered them, we went over them, you guys had a quiz on them. 4 things that make a parallelogram. Now, rhombus and rectangles have specific characteristics to them, and I'm going to write it and I'm going to draw it. Looking at my rhombus, yes, it has 4 congruent sides, which we should be able to know that. I'll draw my little congruency marks. Here are my congruent sides, little black lines. But we also need to know, looking at the first one, Okay, the first thing we need to know is that diagonals are perpendicular. What does it mean to be perpendicular? 90 degrees, good. So here are my diagonal lines as best as I can draw them. They make right angles. They make those 90-degree angles. Okay, second thing you need to know about a rhombus is that your diagonals bisect opposite angles. Diagonals bisect opposite angles. Opposite angles, super important that you know it's talking about the angles. Okay, diagonals bisect opposite angles. So I'm going to show you what that means. Here are my diagonal lines. That's telling me that these two angles that I drew right here are going to be the same. This one is going to be the same measure as this. Let's call them 40 degrees. This is 40 degrees. This is 40 degrees. Right here, these are also 40 degrees and 40 degrees. And then I have these two angles. I'm representing you with two sides now, two marks. This is going to be 50. This is going to be 50 degrees. And same thing over here. Okay, so we can see when we're looking at this that these two are the same and these two are also the same. Same thing with these two bottom ones. So I showed you diagonals are perpendicular and your diagonals bisect opposite angles. You have to remember that. Okay, that's for my rhombus. Now let's go to rectangles. Looking at rectangles, 4 right angles. You have to know that in a rectangle, there are 4 right angles. And I'm drawing it in red. I don't know if you could see it right here. Okay, that's one thing about a rectangle that we know. Also, your diagonals are congruent. So here are my diagonal lines. Let me draw it a little better. Diagonal, diagonal. All of my diagonal lines are going to be the same measure. So I'm drawing like little tick marks. I don't know if you could see them. But these little marks are showing you. Sorry? Yeah. So I'll erase one so it doesn't have the right angles. So you could at least see the diagonals. Okay, so when you're looking at your diagonals, this measure is the same. All of these are going to be the same measure. So if one side or one diagonal, half of it is 6, the other half should also be 6. And then the other two should also be 6. So they're going to have the same measure. When we get into the examples, you'll be able to see that. So just showing you a diagram of what is in what fits into what category. I have quadrilaterals. Okay, quadrilaterals, then I have my parallelograms. Okay, so parallelograms are inside the category of quadrilaterals. Then I have rhombus. Then I have rectangles. And then both of these make squares. Okay, so all of these fall in the category of a quadrilateral. So just kind of showing you what goes with what. Questions on this slide? All right, rhombus theorem. We kind of already covered these. I'm just going to highlight what's important. A parallelogram is a rhombus if and only if the diagonals are perpendicular. So this is where your diagonals meet, which make them all 90 degrees. Rhombus opposite angle theorem. If and only if your bisecting angles are congruent. Okay, here is one angle. These two are going to be the same measure. Here is another 2, and these are going to be the same measure. These 2 are going to be the same measure as well as the ones at B. So this is visually showing you, using the congruency marks, what's the same. Okay, so there's this angle, there's these angles, and then these are represented using 2 lines to show you that those have a separate measure. So please understand, if you're doing one congruency mark and then you're following it with 2 congruency marks, they're going to be different measures. So one could be 6, one could be 8. So make sure you understand that using congruency marks. Okay, now I have a rectangle theorem. Okay, rectangle diagonals theorem. Looking at it, a parallelogram is a rectangle if and only if the diagonals are congruent. Here are my little tick marks. I have 1 mark, meaning they're congruent. So giving you an example, if this is 6, this is also 6, this is also 6, and this is also 6. Please understand the difference between side and angles. Angles have the degree mark. If you do not see the degree mark, it is not an angle. Okay, so when we get into the examples, you'll see some of that. You have to make sure you know what's angles and what is not an angle. All right, looking at this first example, it says quadrilateral. ABCD is a rhombus. So I know it's a rhombus. I'm going to name properties of a rhombus. Who could tell me something about a rhombus? What makes a rhombus a rhombus?
4 equal sides.
Say it one more time.
4 equal sides.
4 equal sides, yes. All sides. 4 sides are congruent. So showing my sides that are congruent. All right, what about the diagonals? Good, diagonals. Make that 90-degree angle, so I'm drawing my right angles. What else do I know? What else do I know about a rhombus?
Diagonal bisects opposite angles.
Good, so diagonals bisect opposite angles. So showing you that this angle and this angle is the same. This angle and this angle is the same. Okay, so I'm showing you using my congruency marks. So I'm going to go ahead and I'm going to label what I already know. So I'm just going to zoom in. What other angles are also 62 degrees? Who could tell me an angle that's 62 degrees?
A.
It's not angle A. You have to be more specific. A specific angle. Oliver? Shh. DAE. Okay, good. This angle is 62 degrees. What else is 62 degrees? Okay, look at my congruency marks. What else is 62 degrees?
BAC.
BAC is also 62 degrees. And what else? I have one more.
DCB.
DCA, good. This is also 62 degrees. How would I find the measure of angle B? I'm going to do some sort of subtraction, but how would I find the entire measure of angle B? Yes, Carlos?
Subtract 62 from 180.
Okay, you're on the right track. So these two angles added together equal 180, but you're only giving me piece of an angle. So first I have to add 62 plus 62. 62 plus 62, it's going to give me 124. Now I can take that 124 and subtract it by 180. So 180 minus 124, what are you going to get?
21.
56. So 56 is left over. This entire angle B right here equals this entire angle. Let me actually draw it in a different color. This entire angle B, that blue little line, equals 56 degrees. How would I find my purple angles? What do you think I have to do with that 56?
Divide by 2.
Divide it by 2. 56 divided by 2 is going to give me what? All right, dividing. 56 divided by 2, cut it in half. Good. So each of these is 28 degrees. We basically found all the information. All right, labeling what we know. What's the measure of angle ACD? ACD, what was it?
62.
Good, it's 62. Write that in there. What's DEC?
Here's what I found.
Oh, gosh.
90 degrees.
DEC is 90 degrees. Yes, I drew a 90-degree angle. What about EDC? 28, good. Just showing you where it is. EDC is right here. ABC is not 28. What is it? It is 56 degrees. Okay, you're adding them together. 56 degrees. Okay, questions on this? All right, looking at the next example, we have a rectangle. What do we know about rectangles? We know that these are 90 degrees. And we also know that your bisecting lines are congruent. So I drew my congruency marks. With me drawing my congruency marks, what is the measure of PON? 90 degrees. It's the entire angle. It's 90 degrees. Okay, we're drawing you 90 degrees. What about the measure of PMO? It is not 29. Good, so you have to subtract. I'm going to take 90 minus 29, and that's going to give me 61. So 61 degrees. And what's PL? Good, 12. And what's MO? 24. You have to add 12 plus 12. Please do not put a degree sign for your lines. They are not degrees. The last question, try and do that one on your own. All right, so looking at your answers, they are on the board. Please check your work. X for A is 3, OE is 16. Check it, please.